Hello everyone. In this video, we will talk about the complete expectation of life. The actuarial notation for the complete expectation of life is EX with a circle on top, and this is the expected value of the future lifetime, the expected value of TX. By definition, to evaluate the expected value, so we will simply take the integral, and then the integrand will be the random variable, in this case t, and then times the density function of Tx. The density function is Tpx times mu x plus t, or we can express this as a negative of dTpx dt. And therefore, the expected value of Tx, the complete expectation of life, equals to the integral from t equals 0 to infinity. The integrand is the random variable t times the density function. Express this density function as negative dt Tpx. To evaluate this integral, we use integration by parts. And the first term here is simply 0. You substitute the infinity into Tpx, we get infinity px, so which is 0. And then the lower limit is 0, so 0 times this one is 0 as well. So the first term is 0. And we get the expression for the complete expectation of life. The integral of Tpx dt evaluate from t equals 0 to infinity. If we have an upper age limit in our survival model, then the upper integral limit is replaced by omega minus x. And this is the formula to get the complete expectation of life. All right, we get the mean of Tx. And how about the variance? Okay, obtained the expected value of Tx squared. By definition, this is the integral. And then the integrand is t squared times the density function. Use integration by parts again. And then the first term is also 0. And we get an expression for the expected value of Tx squared, which is equals to 2 times the integral of t times Tpx, where t is evaluated from 0 to infinity. All right, and then the variance. The variance of Tx equals the expected value of Tx squared minus the square of the expected value of Tx. And then we simply get this expression. All right, so we get the formula for the expected value as well as the variance of Tx. Let's apply this formula with an example. Given the survival function S0, which is 1 minus t over 100, and then we are asked to get the expected value of T20, the complete expectation of life for an individual at age 20, and the corresponding variance. All right, so we need to get TP20, an expression for TP20, which is equals to 80 minus t over 80. And then the complete expectation of life equals the integral of TP20. Evaluate t from 0 to infinity. So we get TP20 as this 80 minus t over 80. We have an upper age limit, okay, because given the survival function S0, the upper age limit is 100. And now the person is at age 20. So the maximum future lifetime is only 80. So the upper limit for this integral is 80. Okay, to perform the integration. And then we get the expected future lifetime is 40 years. And then the variance. We get the second moment. Okay, the expected value of T20 squared. The formula for this is 2 times the integrals of t TPX. So X is 20, and we get this expression. Upon calculation, we get expected value of T20 squared, 2,133. All right, then we can already be able to obtain the variance of T20, which is the expected value of T20 squared minus the expected value of T20, which is 533.33. Another example, given that the force of mortality mu 30 plus T equals 0.01 if T is between 0 and 10, and for T greater than 10, the force of mortality is 0.02, and we are asked to compute the complete expectation of life for an individual at age 30. All right, to get the expected value of T30, we do the integral, okay, from T equals 0 to infinity, the integrand is TP30. Okay, to get TP30, we need to split it into two parts because the force of mortality is a piecewise function. T between 0 and 10 and T greater than 10. For T is between 0 and 10, the force of mortality is 0.01. So we simply get TP30 equals e to the power negative 0.01 times T. And then for T is greater than 10. So that is, we need to get the survival probability starting from age 40. Then we need to express TP30 as a product of 10p30 times TP40. And we can already get 10p30, okay, with this expression where T equals 10. And then TP40, the force of mortality is 0.02. So we get this expression. All right, so 10p30 is e to the power minus 0.1. And then doing the integral here, so this expression, the second term is e to the power minus 0.02 times t minus 10. Upon simplification, for t greater than 10, TP30 is e to the power 0.1 minus 0.02 t. All right, then we can evaluate the integral here. Split it into two terms. One is for t between 0 and 10, and one is for 10 to infinity. The corresponding TP30 is e to the power minus 0.01 t and e to the power 0.1 minus 0.02 t. Upon calculation, we get the expected future lifetime, which is 54.7581 years. That's it for today's video. Thank you for watching. In the next video, we will talk about the temporary expectation of life.